Hello, my name is William Rascompara. Today, my concept diagram is going to be about parental investment and family conflicts. This is a topic from Chapter 12. I chose it because understanding family dynamics and reproductive dynamics within the animal kingdom can help provide more context and more information on the living conditions of animals and their offspring. I will begin with discussing parental investment, which essentially is the different jobs that an organism will take on for the survival of them and their offspring. I'll begin with reproductive strategies. Essentially, reproductive strategies revolves around an organism's main concern to balance offspring survival and resource preservation in the event of future reproduction. An example of this is when female organisms produce fewer eggs but with more available nutrients within them. Creating a low amount of offspring improves the ability for a mother to nurture, but creating eggs with more available nutrients improves the chances of survival of the offspring. This is because it allows for more strong and physically capable offspring that do not need an excessive amount of nurturing and attention from their mother. This allows her to divide her attention and focus on other offspring. These two factors reduce risk on the mother, allowing her to reproduce for another cycle. Here's a picture of, I don't know the exact animal, I want to say a herring, but she's just nurturing her offspring. Hopefully there's some nutrient-rich eggs, but this is an advantage because in turn she's gonna produce more strong, capable, or she'll have to feed less because her offspring will be stronger. So she'll have stronger, more capable offspring. Okay. So next topic will be parental care dynamic. Parental care dynamic is also significant when looking at reproductive strategies, as many times men will be involved in the impregnation of their partner, but sometimes they will have low investment in the actual nurturing of the offspring due to uncertainty of their paternity. This is because, depending on the species, some males will tend to have many partners throughout their lifetime, and they will not always be sure that they are the father of the offspring, leading them to be a little more uninvolved in the actual development of maybe what is or is not their kid. Okay. Next topic will be parental role reversal. Parental role reversal is another interesting example of reproductive strategies. This occurs when significant roles or jobs that are typically sex-based are reversed within a particular offspring. For example, here we have seahorse, or there's another example of pipefish, but I couldn't fit a pipefish on here. They're part of the Syngithidae family. These organisms experience role reversal that's vastly different from the majority of other animals. Males are the partners that undergo pregnancy and nurture the offspring. As a result, females compete for the available males. Males will choose partners based off quality of eggs that they will be able to produce. This is still normal animal behavior, though just in this instance, the male is the one who will birth or be impregnated and nurture the offspring, leaving females to the jobs that typically we see males fill, which is compete for partners, provide physical help in the relationship. Okay. The next topic will be managing family investments. So, this is where animals adapt their reproductive strategies based on factors within their environment and are limited by their genetic capabilities. Parents may adjust the number of offspring or sex ratio of their families in order to ensure increased survival of their offspring when facing predation or lacking food sources. To further expand on this point, there is evidence of maternal hormones changing within organisms to yield particular sexes. I'll dive into an example of that. The environment also plays a big role in the offspring that may be born within a family. Here is an example of environmental conditions and genetic factors within the animal kingdom that may determine particular offspring. Okay, so we start with the soy sheep. So soy sheep, let me get the picture. Oh, where'd they go? Oh, sorry, they're right here. This is a soy sheep. They typically give birth during good climate conditions to improve reproduction rates and to have healthy births. Red deer, the number of offspring will be limited to the food available in their environment. So they don't always have to give birth when there's good climate, but in turn, they're going to give birth based off how much food is available. So you might not expect a lot of offspring in the winter. Have the American goldfinch over here. They adjust their reproduction rate based on predation. So kind of similar to the red deer, not exactly, but if predation is high, they're typically probably going to have more offspring to increase chances of survival of their little habitat or their community. Red squirrels down here will produce more males when in good health. This plays off the sex ratio adjustment of maternal hormones. Um, Red squirrels will probably have more genes. We'll have more hormones to control male production. And then in turn, when males are born, they can spread their genes more easily as they reproduce more. Black eagles undergo siblicide, which is where siblings kill under the facilitation of parents, which ensures that strong offspring survive. There's some examples of this happening with aquatic animals such as sharks. Okay. So now we have intrafamily conflicts. Intrafamily conflicts is a significant part of the parental offspring experience. Parents and offspring may not agree in certain situations, which in turn leads to bigger issues. This occurs with competition for resources. The offspring's behavior around or for food may put the brood at risk. An example of this is with herring gulls. So here's the little herring gull. Is with herring gulls. Typically, herring gulls will perform, especially, the little kids will perform intense begging from the offspring. This has a potential to draw in predators, which could compromise the rest of the family's safety. And then back up, we have sibling rivalry and parental bias. Parents often show preference to certain offspring based off their health. Particular attributes may allow an offspring to stand out and get certain treatment to improve survival. So this is evidence in American coots. So this is an American coot down here. Offspring with brighter and more vibrant mouth colors are favored by their parents, and therefore they are provided more resources as their survival ensures the survival of the brood or increases the chances of survival of the brood. Final topic I will be talking about is theoretical frameworks on family. So these two ideas is Trevor-Wheeler's hypothesis and Fisher's principle of sex ratios. They're basically the same idea, but we'll begin with Trevor-Wheeler's hypothesis. So parents in great health with ideal physical attributes will attempt to focus their attention on their sons, preferably who are similar in health. This is so the sons can reproduce with many offspring and pass on their genes. As mentioned, this is kind of the idea of the red squirrels. They have more males when they're in good health to ensure that genes are passed on and the survival of their brood is improved. This is the son perspective. So now we have a daughter perspective. Parents with poor health and poor physical attributes will tend to focus their attention on females, invest more time, more nurturing, and resources on their females. This is due to their high reproduction rates, which in turn can help continue the survival when males are not surviving. Many females will in turn have many offspring. It is not the most efficient mode of survival, but it works when there's not a lot of resources. The final topic will be Fisher's principle. It essentially plays off of Trevor's hypothesis, and also the sex ratio idea. Deviations of sex ratios may happen in situations where having more males or females is favorable. This is due to reproductive success of the offspring, but will depend on environmental and other factors.